In the previous video clip, I introduced route summarization. Those were LSA type 3, which means that we were able to summarize prefixes, let's say from some area into area 0, and this area 0 would propagate them into area 5, for example, as summary route already. So these were the ABRs, and area range was the command. In real life, sometimes the company acquires another one, and that other company runs different protocol than OSPF, for example, EIGRP. Now we need to introduce those prefixes into OSPF, unless we can change the EIGRP domain overnight into OSPF, probably not going to happen. So for the time being, I need to introduce maybe those external prefixes from EIGRP, in my case, into OSPF. And it doesn't have to be this process is called prefix redistribution. It doesn't have to be connected to area 0. It can be connected to any other router in any other area. What happens though, when we do this prefix redistribution into OSPF from other routing protocol, they show up as LSA type 5. There's also LSA type 4, but I'm going to talk about this in a different video because I don't want to keep this video too long. So what I did so far, I prepared here on R2, I created two loopbacks, loopback 10, show run interface loopback 10. The 10.2.2.1 is the first host in the subnet 10.2.2.0 with a /29. So show interface loopback 10 include address. That's a mask /29 bits. And the same thing is for loopback 11. So the subnet is 10.2.2.8. The first host is 9. And what I'm going to do here in R2, I'm going to run another routing protocol on this box on R2. I'm going to run EIGRP Autonomous System 100, and I'm going to run this protocol on the interfaces loopback 10 and 11 this way. Network 10.2.2.1, match on all bytes, and 9. So as of this moment, I'm running EIGRP on those two interfaces. There are no other routers running EIGRP here, so it's just this one. Do show IP EIGRP interface, just a verification, quick verification. I am running EIGRP on those two interfaces. Now, as of this moment, R1 doesn't have a clue that this subnet or that subnet even exists, because they're running EIGRP, so OSPF doesn't have a clue what that means. But if I do introduce those into OSPF via redistribution, we will learn them as LSA type 5 or external type 2 by default. And again, there's type 1 and type 2. That's maybe a topic for another video. But for now, I want to do one thing. I want to introduce those external prefixes into OSPF as LSA type 5. So what I do, I create on R2 this configuration. I am jumping back to our OSPF process, and now there's two protocols running here. I'm going to say redistribute everything that EIGRP 100 knows and introduce them into OSPF with exact subnets as configured on those interfaces. Now this keyword is necessary, otherwise these two would show up as as one prefix 10.000/8. So this way I will introduce them as 10.2.2.0/29 and 10.2.2.8/29. So if I go back to my R1 now, it should already know how to reach this subnet, and it's learned via OSPF. Distance is 110, metric 20, type external type 2. For metric 20, we'll talk about that later. But for now, it is available as external type 2. So what it means that if I do show IP route OSPF, I see them as E-type 2 here, both subnets. Now, like we did with LSA type 3, then they can be summarized if the bits, if those two subnets, let's say, are contiguous, and they are. I actually prepared quickly already those subnets converted into binary. So this is the subnet 10.2.2.0/29. So this is 29 bits of subnet mask, which is basically this value 255, 255, 255, 248. And there's a subnet 10.2.2.8 right here. And the mask is, so those 29 bits are masked. And these are network address, network portion, leaving 3 bits for hosts. Now I can do summarization. So summarization is again finding the common number of bits that never change. All these columns never change. And this is up to this point, because here we have 1, so on that bit we have a change. So we have to unmask that, makes this now mask /28. Let's go back here, and the value here is 240. So the same rules as in previous summarization of inter-area prefixes. We find a common number of bits that don't change, we mask them, and we get the value. So the command is going to be different. We cannot use area range because this is not area, this is an external prefix. So what we're going to do here is on R2, let's go to R2. Inside the routing process OSPF, the command is summary address. And I introduced, like previously, the lowest value of my subnets with a shorter mask. So 255, 255, 255, 240 this time around. There's a bunch of options, but they are not relevant to this particular summarization here. If I hit enter, what should change is those 2 subnets should be now replaced with 10.2.0/28. Let's see that happen. And sure enough, we have it. Do we have reachability to do both? Of course we do. So if we ask specifically, do you know how to reach subnet 10.2.2.0? I do. What about 8? I also know. So ping 10.2.2.1 and 9 work. One last thing is that they show as LSA type 5 in OSPF database. So if I ask show IP OSPF database, this is an internal router for area 0. At the very bottom, I see now type 5 LSA introduced this prefix. And this is the address or router ID of ASBR. Now, I can also ask specifically, show me external prefixes. And this shows me the details. So I see now this subnet 10.2.2.0/28. And the forwarding address 00 means that the router that advertised is the best next gateway to reach that network, because sometimes it can change. And that basically is a summarization of LSA type 5 prefixes.